Solve the following pair of simultaneous equations. So here we've got a pair of linear simultaneous equations, and the most common way of solving these is by elimination, by which I mean we can make the x values the same. So here we could turn this into 15x and this into 15x, and then we could eliminate these by subtraction. We could also turn these into 15y and do the same thing that way. So if we're going to do that, and we were going to turn the x term into 15x in both equations, we do that by multiplying the first one by 5 and the second one by 3. And that would then give us 15x plus 25y equals 170. If I multiply the second line by 3, I'll get 15x plus 9y equals 90. And that's number 4. So I've made two new equations here, number 3 and number 4, and here they've both got 15x as this first term. So if I'm going to subtract them, if I do number 3 take away number 4, 15x take away 15x will just disappear. Then I'll have 25y take away 9y, which will be 16y. 170 take away 90 is 80, and divide both sides by 16 gives y is 5. Once we've got that, we can substitute back in to get the other value. So substitute back into number 1. So we've got 3x plus 5 lots of y, which we know is now 5, gives us 34. So 3x plus 25 is 34. So by subtraction of 25, we get that 3x must be 9, and therefore x is 3. It's a quick bit of substitution just to make sure that it's correct. So into the second one, we've got 5 lots of x, 5 lots of 3, which is 15, plus 3 lots of 5, which is 15, so 15 and 15 is 30. And we've checked it in the other equation, so it works. Solve the following pair of simultaneous equations. xy equals 6 and 5x minus 2y equals 7. So we've got a non-linear statement and a linear statement over here. Now where that is the case, we can't solve them by elimination like before, so we need to use the method of substitution. So we're either going to rewrite this line in terms of x or y and substitute it into here, or vice versa. I'm going to choose to rearrange this part here in terms of y, and then I'm going to stick it up into here. So I'm going to move this around so it's in the form y equals something, and then I'm just going to dump it all into there. So and there's lots of different ways you could do this bit. Hopefully you'll always end up with the same thing. So I'll get 7 add 2y is 5x. So pulling the 7 over gives me 5x minus 7 equals 2y. And then I'm going to divide 3 by 2. And you could, if you wanted to, have split this here into 5x over 2 minus 7 over 2. But it's the same thing. Now, since I know that y is now equal to this, I'm just going to put this lot in its place here. So I've got x from here. And then instead of y, I've got this lot that I now know it to be, which is 5x minus 7 over 2. And that equals 6. So if I expand that all out, we get 5x squared minus 7x over 2 equals 6. I need to get rid of the fraction, so we'll multiply that away. So we get, in the next line up here, 5x squared minus 7x equals 12. So we're going to have a nice quadratic here. So if I just pull the 12 over to get 5x squared minus 7x minus 12 equals 0. Now, hopefully this will factorise, but if it doesn't, we'll be using the formula here. So let's just do a little check. You might do this a different way to me, in which case you might want to look away now. So 5 times minus 12 is minus 60. So I'm looking for two numbers that can multiply together to give me minus 60 and add together to give me the central term, which is minus 7. So that's got to be minus 12 and 5. So I'll make a note of that. So this is the bit some of you will do differently. So I'll call that 5x minus 12 5x plus 5 equals 0, and then that'll factor down to become, divide this lot by 5, so that becomes x plus 1 equals 0. So from there, my solutions in terms of x will be, when this one's 0, x will be 12/5, or this one's 0, x will be minus 1. So I need to find the value of y, because it's a simultaneous equation. So I'm going to substitute back into the top one. So we've got 12/5 y equals 6. So multiplying through by 5 gives us 12y is 30. So y is 30 over 12, which is otherwise known as 5 over 2. So that's one pair. So we've got when x is 12 over 5, y is 5 over 2. And the other one is when x is minus 1. And when x is minus 1, we've got minus 1 y equals 6. So y must be minus 6. Solve the following pair of simultaneous equation. So here again we've got the equation of a circle up here, and we've got a linear statement down here. So obviously it can't be solved by elimination, because nothing's going to cancel no matter what you multiply these terms by. So we need to solve this by substitution. So easiest thing to do here will be to rewrite this second line, this linear statement, writing it in terms of either x or y. Because there's 2y here, it probably makes more sense to leave this in terms of x. So that's what we're going to do. So to do that, if we take away the 2y from both sides, we get that x is 9 minus 2y. And since we know that x is 9 minus 2y, we can just stick it back in the other one. So that will give us, instead of x, I'm now going to have what I know x to be, which is 9 minus 2y. So 9 minus 2y all squared, adding to that the y squared, which is still there, and that all equals 45. So now we just need to solve this, expand it, and then set it equal to 0. So that's a double bracket expansion of 9 minus 2y plus y squared equals 45. So when we expand all this out, we're going to get 81 minus 18y minus another 18y plus 4y squared plus that extra y squared that's lying over here equals 45. Tidying all up to make it look a bit more presentable will give us 5y squared minus 36y plus 81 equals 45. So we'll bring the 45 over, so taking the 45 away from both sides. We're running out of space on the bottom of this page here, to give us 5y squared minus 36y plus 36. And that now is all equal to 0. So from here, we'll hope it factorizes. If it doesn't, then we'll again, like last time, go with the formula or completing the square. So let's try and test this out. So 5 lots of 36 would give us 180. So we're looking for something that multiplies together to give 180 and adds together to give minus 36. So that's got to be minus 30 and minus 6. Yeah. So minus 30, minus 6. So I'm going to stick these in. Again, if you've got another way of doing this bit, feel free to just do it your way at this point. So 5y minus 30 and 5y minus 6 equals 0. Pulling out the factors of one of these, this divided by 5, so we get y minus 6, and 5y minus 6 equals 0. So solutions from this point for y are that y is either going to be 6 for this bracket to be worth 0, or for the other one to be worth 0, y would have to be 6/5. So obviously that's not finished until we've got the value of x corresponds to each of those. So substituting back in, probably going to go back into number 2, I think here looks a little bit easier. So when y is 6, we've got x plus 2 lots of 6, which should become 12, equals 9. So x has to be -3. So we've got one pair, which is when x is -3, y equals 6. And for the other one, it's putting 6/5 in. So I've got x plus 2 lots of 6/5, which would be 12/5. And that equals 9. So by taking that away from both sides, we're in effect taking away 2 and 2/5. So it's 9 take away 2 and 2/5. And the answer to that is 6 and 3/5. So the other solution lies where y is 6/5, and that is x is 6 and 3/5.